it is important to be able to find the antiderivative. If you're going to use the fundamental theorem of calculus, which, again, let me remind you, looks something like this. The integral from a to b of f of x, in fact, let's not even worry about that now. Let's just say the integral of f of x, yeah, actually, I'm sorry, we do need that. We're going to evaluate this. If we're going to integrate from a to b of f of x dx, we need to know f and little f, right? This is the first fundamental theorem of calculus. It says if we have some function, we're going to integrate it from a to b, we got to know capital F. What is capital F? It is the antiderivative of the function. So what I'm saying is, if you can't find the antiderivative, guess what you can't use? Fundamental theorem of calculus. So you can see how that could be a problem. All right, well, look at this lovely guy. Integrate 2x square root of 1 plus x squared. Now, I'd like you to scan your memory here, and I'd like you to think about what the antiderivative is of this. And I'm going to guess that most of you don't know. We're going to need something a little bit more sophisticated. If the only thing we can integrate are the things that we know antiderivatives of, we're not going to get very far. So to find this integral, we need to use a problem strategy of introducing something extra. Talk about that here in the coming slides. Here, the something extra is a new variable, which is I'm going to use u. That's why we call it u sub. Oh, and I guess I should make sure I say this before we go too far. What I'm getting ready to show you today, after time becomes very easy to do in a second nature, it may not feel that way today. Just trust me that it eventually it kind of kicks in. Some of you might just get it right off the bat, and that's fine. Let me do an example. So here's example number 1. Suppose that we let u be the quantity under the square root. In other words, we're going to let u be this right here, this x, or 1 plus x squared. In fact, I'm going to write it separately here. So I'm saying we're going to let u equal 1 plus x squared. All right? And you might say, Mr. Allen, why are you doing it? Just trust me. Okay? If that's u, what would du be? What would be the derivative of u? What is the derivative of 1 plus x squared? 2x. And then we got to add, screw this up here. Let's not do that. 2x. That's right. And then you need to add this dx. Now, guys, I'm going to emphasize this right off the bat because many students forget this. And if you forget this dx, you could lose points on the AP exam. And I don't want you to do that. What I'm doing here is I have said that u is equal to 1 plus x squared. And then I said, okay, do the derivative of u. So we'll call that du. Technically the differential. And then do the derivative of the right-hand side. And then we did 2x. And then that's technically the differential of x, or dx. Okay? Okay, and by the way, I have all this stuff right here. So now here we go. Now we're going to do this substitution. What is this? What is this 1 plus x squared now? It's u. So this becomes the square root of u. What is the stuff in green? What is 2x dx? It's the du. And we're still integrating. Now, I'm going to stop here for just a second. I obviously have, I think it was obvious. I haven't finished the problem, right? We haven't gotten the answer yet, right? But I just want you to think about this for a second. Would you guys agree that this multicolored integral that I have right here looks a lot easier than the one we originally had? Wouldn't you agree with that? In fact, you could do that integral. That's the whole point. Okay, so let's go ahead and do that integral. And so I'm going to say this is now transformed into this. Now, I like to do this. I always like to write my square roots as exponents 1/2. And the reason I like to do that is now I can use something called power rule. You guys remember the power rule? So to do the power rule, I'm going to add 1 to the exponent, which is going to make it u to the 3 halves. Remember, you got to add 1. And then you got to divide by that same amount. So I'm going to divide by 3 halves. And then, of course, don't forget what you have to add, plus that constant of integration. Now, guys, I'm still not done, so don't put your pencil down just yet. You guys would agree if I divide by 3 halves, that's the same thing as multiplying by 2/3, right? So I'm gonna kind of come up over here now. So that's going to be 2/3. All right, my arm gets a little bit too close to the smartboard, and it does that. 2/3 u to the 3 halves plus c. But wait a minute. Did this problem have any u's in it? What was u? That's your answer. Oops. Don't forget the exponent. Now, guys, I kind of went through that pretty quickly, and I did it pretty confidently because I've been teaching this class a number of years. Let's say you're doing problems like this in the coming days, and you're not feeling very confident. How can we check this answer? How can we check it? Well, what we could do is just differentiate it, right? Isn't that what I've been trying to tell you back when we did section 4.1? I said, if you're not sure if the answer is right, just do the derivative of it, right? So let's just, I'm going to check it now, okay? I'm going to erase this work up here if you guys don't mind. I'm going to check it. So I'm going to erase this part, which I probably shouldn't do, but I already had it written up there in the text, so that's going to be okay. And I'm going to do it, and let's just do it in purple. So I'm going to put the check right here. Here's my check. So what I want to do is I want to do the derivative with respect to x of 2/3 1 plus x squared to the 3 halves plus c. I want to do that derivative, right? Okay, first of all, let's do the easy part. What's the derivative of a constant? 0, right? That's 0. More importantly, so this guy's 0, so that c is going to go away. What rule do I need to do the derivative of that thing, though? The chain rule. That is exactly right. So here we go. I'm going to do the chain rule. So using the chain rule, I'm going to get 2/3 times, remember, you got to bring that power down, leave the inside alone, reduce that power by 1, and then what am I going to multiply by? The derivative of this stuff on the inside, correct? And what is the derivative of the stuff on the inside? It's 2x. And I'm going to go ahead and write plus 0 here, but right from that guy. Now, this looks like a hot mess right now. You're probably thinking, Mr. Allen, I am so lost right now, but just trust me. What's 2/3 times 3 halves? And if you guys don't mind, I'm going to put this 2x in the front, and I'm going to change this 1/2 to the square root again, okay? You guys mind if I just put this 1/2 exponent, same thing as square root. And I want you to look at this right here, and I'd like you to compare it to our original problem. Now, I'll be honest, my first couple years teaching this, I would have just given you this answer right here and I would have said, move on. I just took a few minutes to show you the check. Because sometimes students feel uncomfortable about what they did. They're not confident. Guys, this is a great way to review differentiation. Plus, once you do it, you will feel very confident about your answer. Right? Do you have to check all of your answers? Of course not. Is it a good idea to check one if you don't feel confident about it? I think so. Okay? Any comments or questions on example number 1? Okay, by the way, if you look at the next slide, you will see that there's all the work that we just did. So it's already typed in case you didn't write it down the check stuff. All right. All right, so by the way, I just did the substitution rule without telling you the substitution rule. This is the substitution rule, and you'll notice that it's worded, it's not intuitive when you look at it, but here's what it says. If u is equal to g of x, so this g of x right here is actually u, is a differentiable function whose range on an interval I and f is continuous on that interval I, then the integral of f g of x, g prime of x dx is equal to f of u du. So once again, just like when we looked at the fundamental theorem of calculus part 1s and part 2, these rules almost they're so simple it's almost harder to understand them, right? That's actually why I started off with an example. Okay? Let's look at another example. Now, I'd like you to, when you look at that, I would imagine you're probably a little scared of that. Doesn't that look really scary? I mean, not like terrifying, like you're going to be hurt, but like, oh man, I hope Mr. Brown doesn't ask me what that question is. I don't know how to do that definite integral. So here's the first thing that we've got to do. The first thing that we need to do is we need to think about what is u going to be. And I'll give you a hint on how you figure out what u is going to be. You want to also simultaneously think about what d is going to be, or du is going to be. In fact, let me go back to that last example that I did if I can. Let's see if it'll let me go back. Oh, I erased it. Oh, I got it up here though. That's okay. Remember I said let this be u, and this is going to be the du? I picked this for the u because guess what I knew about this part? This 2x is the derivative of 1 plus x squared, isn't it? So now let's look at this new, harder looking example. Do you guys see this? And do you see this? Now, it's not quite right, but would you guys agree that the derivative of x to the 4th plus 2, if you do the derivative of that, it's something x to the 3rd? That's what we're going to do. All right, so this problem's going to be a little bit harder. By the way, if you didn't watch my video that I already posted on Canvas before class today, I posted it on Friday morning at 9 a.m. If you didn't do that, and you're feeling a little overwhelmed right now, I would just like to encourage you to watch that video that I made. By watching that video, you would probably feel a little bit more comfortable about what I'm doing right now. Now, in order for you to watch that video, it requires you to be disciplined and say, you know what, I'm going to watch that video just so I have some idea of what Mr. Brown's going to do today in class. Okay, so I'll move on. There's my little soapbox. Okay, so I'm going to let you be x to the 4th plus 2. And the reason I picked that is because I know that the derivative of that is something like x to the 3rd, but it's not x to the 3rd. What is it? It's 4x to the 3rd, and then don't forget to write dx. Now we have a little bit of a problem now. The problem is I now can put u in for this, so that's wonderful, but is this right here exactly du? Not quite. In fact, remember, I want to think about this with that dx, right? I'll go on it. Guys, I'm really sorry about that thing. I don't know why it always says that. So x to the 3rd dx, it's not quite. What's the difference between those two? That's exactly what you need to divide it by 4. So I'm going to go ahead and I'm going to do this in a different color so it kind of stands out. What happens if I divide both sides by 4? In other words, divide that side by 4 and then multiply that side by 1/4. Same thing as dividing by 4, right? So what that tells us, and I'll go ahead and just leave it in purple, is that 1/4 du would be equal to, now what happens to the 4's right there? Well, now you get that x to the 3rd. That's what I wanted. This is the difference between the first example and this next example. Now I'm going to rewrite my integral. Okay? Let's do it in blue. Let's do the dark blue. So this is now going to become the integral Now, what am I going to put in for x to the third dx? What am I putting in for x to the third dx? Well, I'm putting in this right here, right? 1/4 du. So I'm going to put 1/4, and then I'm going to go ahead and put du right there. I'm going to leave a little bit of room, okay? Go to green. What am I going to put in for this thing? Not u. It's not u. It's cosine of u. It is the cosine of u. All right? This part is u. This part is cosine of u. So it's the cosine of u. Now, let's do that in blue again. You guys hopefully remember that that 1/4 is a constant, so that means we can just pull it out, right? That's one of those rules we've been talking about. We did that with limits. We did that with integrals. We did that with summations. We're using it right now. We can pull up the 1/4. By the way, I want you to ignore the 1/4 for just a second. Would you guys agree that this integral here looks a lot friendlier than the original beast that we were looking at? Looks a lot better, doesn't it? So now we can go, by the way, what is the antiderivative of cosine? Sine of u. So this simply becomes 1/4 the sine of u okay? Plus c, don't forget the plus c. Don't forget the constant of integration. By the way, is that our final answer? What's the only thing I had to do with that u? Just change it to the x to the 4th plus 2. So this is, the final answer is 1/4. Oops, and I'm getting right cosine. It wasn't cosine, it was sine. So this is the sine of x to the 4th plus 2 plus c. All right. Is it okay if I don't check this answer? Is that okay? I'm going to check the next one. We could check this one by differentiating. Do I want to do that right now? No, I'll check the next one, okay? Just trust me if that I did it correctly. If I wanted to check it, I could go ahead and differentiate it. But I'm going to go ahead and do another example before I do another check, okay? So remember, here's kind of the gist of what we did. We had this scary, in fact, let me erase all of these markings up here. Get rid of all this stuff. We had this scary looking integral, right? And when I say scary, I mean it looks difficult. But we noticed that this x to the 4th plus 2, when I do the derivative of that, it's kind of like something x to the 3rd. So that allowed me to say that u is going to be x to the 4th plus 2, then du would be 4x to the 3rd dx, and then I can divide both sides by 4, and then everything worked out real nice. This is the crucial part of these problems, is setting up the u and the du. Okay? All right, I'm going to do one more here, and then we'll talk about something a little bit different. This says example 2. I guess the first one I didn't call an example. Oh, well, okay. So this says find the general solution for this. Remember, this is called a differential equation, right? We've already talked a little bit about differential equation. All the differential equation is it's an equation with a derivative in it. Remember, this is the same thing as saying y prime equals e to the 5x, right? That's a differential equation. How do we solve a differential equation? Well, you got to get rid of the derivative. How do we get rid of derivatives? You integrate. So y is simply going to be the integral of e to the 5x dx. By the way, this problem is easy enough that I think some of you could just do mental math. If you want to try to guess on what you think the answer is before we get there, that'd be fine. Does anyone in virtual land want to just type in the chat, what do you think u is going to be in this problem? What would u be in this problem? Anybody want to take a stab on what you think u is going to be? Okay, good. I see e to the 5x. All right, so e to the 5x. Any other guesses or, ooh, 5x I hear. Okay, so u might be, I'll call this u1, this is u2, that's 5x. Any other guesses? All right. So if you guys don't mind, I'm just going to go with Hayden's first guess here, all right? We're gonna try this first. So let's just pretend that you're doing your homework or whatever. You think, I'm going to let u equal e to the 5x. So if that's the case, let me do this. I think I'm already in purple, so this will work. So this is just going to be the integral of u du, right? But wait a minute. What would du be in this case? What would du be? What's the derivative of e to the 5x? Well, you have to use the chain rule, right? So it would be 5e to the 5x dx. That would be du, correct? So here's my question. Let me go ahead and go back here a little bit. What am I going to put in for this? Well, we would put in u, right? What would we put in for that? Doesn't quite make sense, does it? My concern is here I put in u, and then I guess we could maybe divide this over. Well, let's see what happens if we do that. We divide both sides by 5e to the 5x on both sides. 5e to the 5x. So then this would cancel, right? This would cancel. So in other words, what do I have to put in for dx? That, right? So then this would become du divided by 5e to the 5x. Now we have a major problem now. Do you guys see what the problem is? The problem is we have variables u and also variable x. That's not good. We do not want that. You guys are not taking multivariable calculus, so let's not worry about multivariable calculus. So Hayden, you have a very good guess there, but it is not going to work, okay? So we're gonna have to try, let's go ahead and try Rachel's suggestion here. So I think she said 5x, so let's give that a whirl. So I'm just gonna call this u now, so that's u. So du would be what, 5 and then dx, right? The derivative of 5x is just 5 dx, great? The problem is do you guys see an extra 5 up here? So what am I going to do with that? Just divide it over. I hear someone saying that's right. So I'm going to say, I'll write it this way this time. So du is going to be du over 5 is equal to dx. So now when we go back to our problem here, so what are we going to put in for 5x? U, right? So this is going to be e, oops, let me have the eraser now. E to the u. What are we putting in for dx? What is dx here? It's du over 5, right? In other words, y is equal to 1/5 the integral of e to the u du. What is the antiderivative of the e to the x or e to the u? It's just e to the u. Don't forget the plus c. Am I done? Nope. How do I finish it? Yeah, just change the u to 5x, right? I'm going to move this up here. So then our final answer here is going to be 1/5 e to the 5x plus c. That is our final answer on that one. Now, I am going to check this one. Let's see if I've got room to do it on the next slide. So, if you guys don't mind, I'm going to erase some work that I've done here. I'm going to erase this. I'll put it back maybe later. Okay? But I want to check this one. I'm trying to make a somewhat important point here. Cool. I hope someone makes a connection. Okay, so here we go. So here's our answer. How do we check our answer? Just do the derivative, undo the integration, right? So we want to just check to see if this is correct. So to do the check, I'm going to do the derivative of 1/5 e to the 5x plus c. We're going to check it, okay? Again, what's the derivative of c? 0, right? That's 0. Now, in order to do this derivative, what rule do I need to use? I have to use the chain rule. So here we go. The derivative is going to be 1/5 e to the 5x, and then you have to multiply by the derivative of 5x. What is the derivative of 5x? It is 5. And again, I'm going to go ahead and put the plus 0 there, just to make sure everyone realizes that c did turn into 0. Oh, guess what happens to this 1/5 and that 5? It disappears. So you're left with this, which, by the way, was what we wanted. Now, guys, I've done 2 problems like this. Actually, I've done 3, but 2 of them I've checked. In both cases, what rule did I use to check my answer? What differentiation rule did I use? Very important connection. U substitution is like the chain rule for integration. That might be something to write down in your notes. U substitution is like the chain rule for integration. Okay, so I've done 3 examples of chain rule. Now let's go ahead and talk about something a little bit different. So up to this point, every problem we did, and I don't want to go back through all of them, on all of them we put that plus c, right? Because those were all what we call indefinite integrals. What if we wanted to use chain rule with a definite integral? So this is the last thing I want to talk about today. I've got, I think, 1 or 2 more examples. Maybe 2. Oh, I got to talk about symmetry too. I'll talk about symmetry real quick. Anyways, so what if I wanted to integrate this definite integral? Well, you would have to use some u sub and the fundamental theorem of calculus, and you'll get your answer of 26/3. But what I want to do now is actually, I'm going to just go ahead and show you an example. Okay, it's the same one. Ready? Do me a favor, ignore the 0 and 4. I'm going to speed up here because we're running out of time. Can you guys guess what u is going to be here? Yeah, it's a great guess, 2x plus 1. If you guys don't mind, I'm just going to go ahead and jump right into it. That's u. By the way, what would du be? 2 dx. Don't forget to put the dx. Now notice up here, there's a dx, but there's not an extra 2 floating around. So what might I do? Divide by 2. So I'm going to have 1/2 du equals dx. So now we're getting somewhere. This it's like I'm doing the same thing I just did over again. So I've got my u, and I've got my du now. All right, so here's the part that's different. This is called change of base. Okay? You see this 0 and this 4. I'm going to change them. If x is equal to 0, what would that be in terms of u? 1. You put 0 right there, what do you get? 1. Top one. If x is equal to 4, what does that change to? 9. Because this is our definition for u, correct? If this is in terms of, everything in the original problem is in terms of x. So if x is 0, then that would make u equal to 1. If x is 4, then u would have to be 9. In other words, what I'm telling you is, this entire integral changes to the following. First of all, would you guys agree that that 1/2 is going to come out in the front? Did it again. We've used that property many times. It might be my favorite property. Now, I still got this square root thing here, but what am I putting in for 2x minus, or 2x plus 1? Putting in u. And now, here's the big parts of emphasis. What am I putting for my lower bound of integration? 1. What about my upper bound? 9. Correct. Now, guys, I would like you to look at that integral, and I know this isn't a super complicated one, but would you agree that this integral looks better than the original? and we're going to be able to do it, okay? So I'm going to go ahead and do like I said, and I'm going to change that exponent to 1/2, right? We've actually already done this here today. What is the antiderivative of u to the 1/2? What's the antiderivative of x to the 1/2? Well, you're going to add 1 to the exponent, and then you have to divide by it. And if I remember correctly, I think it was like 2/3 u to the 3/2, agreed? We did that earlier, so I'm kind of cheating a little bit. We did it, I think, on the very first example. Now, what I got to be careful of is what was still in the front there. You see that 1/2? It's still there, so it has to stay there. It doesn't just magically go away. Now I'm going to evaluate this thing from, instead of going from 0 to 4, I'm going to integrate it from 1 to 9. So there's all my work, and I'm going to finish this out here very quickly. By the way, guess what happens to this 2 and that 2? You guys would agree that this will cancel that, agreed? In other words, what I'm saying is you're going to get 1/3. We got to do 9 to the 3/2 minus 1 to the 3/2, right? That's the fundamental theorem of calculus. Okay, what is the square root of 9? To the 3rd. 27. So this is going to be 1/3 times 27. And what's 1 to any power? 1. And so guess what our final answer is? 26/3. Now, guys, I'm going to come back to this slide. I'm going to go back to this one here. This is the exact same problem, but I did not use change of base. The answer was already there. It's 26/3. What I did is I used, change of variable is what it's called, change of variable. And guys, it just did it again. This is the change of variable. I literally changed this whole problem from an x integral to a u integral. Make things just a little bit easier for me. Yes?
So if you kept the 0 and the 4, you could plug in u for the original equation thing, and then you could do it in terms of the original integral.
So the question is, and I know you guys online can't hear me or hear what he's saying. I think, correct me if I'm wrong. So first of all, let's just accept that what Mr. Allen did here is correct, and it is. The question I think is, hey, Mr. Allen, could I have kind of done what we did in the previous slides, integrated this, found the antiderivative, and then changed everything back to x's, and then plug the 0 and the 4 and get the same answer? Correct. Here's my advice. You're doing an extra step then, and that's fine. But if you're doing the u sub, why don't you just go ahead and leave it in terms of u, and then you don't have to convert it back to u. So this is just a little bit more efficient. But if you want to do that, like if I'm not going to go back again, but if I go back 2 slides, that when the problem was originally done, and I kind of skipped over it, that's the way it was done. And yes, you can do it. You have 2 different ways to do this. And some people hate that. But in my opinion, anytime I do a u sub, I just leave it in terms of u. Okay? Any other questions before I move on? I don't know if I'm going to do any more change of variable problems. I need to talk a little bit about symmetry, though. We have about 5 minutes before my 60 minutes is up. By the way, those of you that are playing at home, there's a poll question that I think is super easy, I think. Okay. Here we go. I'm not going to do this problem. In fact, let me just do this. I'm going to give you the answer and the u sub. So my guess is you probably could figure out that u in this problem is going to be 3 minus 5x. du would be equal to negative 5 dx, which then, of course, you would divide over. So here's your u for this problem. Here's your du for this problem. And again, you're going to change the 1 and the 2 using that change of variable thing. you will end up getting a final answer of 1/14 on this one. I'm going to skip this example, and I apologize for that, but I am kind of a stickler for honoring your time, and I don't want to go over if I don't need to. So anyways, it's the same idea. This one's a little interesting, though, because you're going to have 1 over u squared, so you're going to write that as u to the negative 2. Anyways, I can go over that later. All right, last thing. You guys hopefully remember what symmetry is. You studied it in pre-calculus. There are 2 types of functions that you need to be aware of. They are called even functions and they are called odd functions. So for example, an even function would be the cosine function. Cosine of x is an even function. The reason it is an even function is because if you plug in negative x, let's call this f of x, in for the variable, guess what you'll get out? F of x. Now you might say, what the heck does that have to do with symmetry, Mr. Hunt? So here's another way to think about it. The left side of the graph, guess what it looks like? It looks exactly like the right side. Left side looks exactly like the right side. In other words, let me draw that cosine curve here, okay? So let's pretend this is the x and y axis, okay? So here's our cosine curve. It goes like this, right? It comes down and comes up. Guess what it does on the other side? The exact same thing. The left side is a mirror reflection of the right side. That is what we call an even function. The way we test it is we plug in negative x and we get out, or f of negative x gives us f of x. We also have an odd function. You want to take a guess on what an odd function is? I'll give you a hint. It's not cosine. It's sine. Sine is an example of an odd function. An odd function, when you plug in negative x, guess what you get out? Negative right there. You get negative f of x. Okay? Anyways, I don't want to spend a bunch of time reviewing pre-calc stuff, but that's the big idea. Here's what you need to know. In fact, let me see what we've got. Okay, so here we go. This is a graph of an even function. So if I asked you, what is the integral from here to here, instead of calculating that whole area, what you could do is just take that area times. Do you understand that? That's what this is saying. Similarly, but different, if you have an odd function like this one, and you integrate from negative a to positive a, guess what the answer always has to be? A 0. Because the negative stuff on that left will be exactly the same area as the positive stuff on the right. So I'm going to do this final example here. I've got 1 minute here. It's right at 45, and we'll finish things up. So let's go ahead and look at this. It says use the symmetry properties to integrate the following function. Now, guys, what do you think? Is this, and by the way, you probably can guess just by looking at it, is this one even or odd? Let me write it a different way. This is maybe one of those things where your pre-calc teacher maybe didn't tell you something that maybe they should have. Can you guess what kind of function this is?
Even.
Look at the exponents. What numbers do you see? Even numbers, right? This is an even function. And the way we know it's an even function is if I plug in negative x, I'm going to get negative x to the 6th plus 1. What is negative x to the 6th? It is x to the 6th, which, by the way, is equal to the original function, so therefore it's even. So if I want to integrate this from negative 1 to 1, instead of doing negative 1 to 1 of f of x dx, 0 to 1 f of x dx, but what do I need to add in addition to that? Correct. You need to add this 2. Now I'm going to go ahead and do it because this is a super easy problem for me to do that with. So again, let me explain what I'm doing here. And I'm sorry this thing keeps, here we go, I got it. Keeps doing that to me. Apparently my arms are so massive I can't even walk by the board. But anyways, so In this case, what is the antiderivative of x to the 6th plus 1? Yeah, we're going to use our power rule, right? So what do I do with the 6? I add 1, right? So 6 plus 1 is 7. Divide by 7. What's the antiderivative of 1? Hopefully you know that that's x. And then I just need to evaluate that from, in this case, 1 to 0. By the way, I hope you realize that evaluating this expression for 0 is 0. That's what makes this one easier. Now I just got to plug in 1. So this is going to be 2 times 1 over 7 plus 1. And what's 1 plus 1 7th? I think that's 8 sevenths. And then take that times 2. I think that'd be 16 over 7. And that's your answer. Okay, guys, I'm going to wrap it up there. I'm going to double check that I got the right answer, which I did. I'm going to send you my exit slip. We are a couple minutes over. I apologize for that. If you would please complete the exit slip before you do anything else, that would be fabulous. And then I'm going to stay on here. I'm available for the next 30 minutes for support. You can either A, ask me questions, B, start working on homework, or I'll let you fill in what C is. If you have questions, though, please let me know. Please complete the exit slip before you leave. You guys were virtual last week. You know how last week I started doing the presentation of like the whole window? Did that look clearer to you as a student? Was that more helpful than when I was kind of standing in front of them? Mr. Lakin does that, so I was trying to. Those of you that are left on the virtual, if you have any questions, please let me know. Does anybody have any questions in here on what I did? You said. Audrey, did you paste something in?
Yeah, Riley.
Just by accident?
No, she tried to get on her
Sorry. Riley, if you can't get on there, it's
Okay.
this isn't for a grade, I just like to get people.
Yeah, no.
Thank you.
I'm trying.
Yep. Is that just the, is that just the one?
Yeah.
Congratulations, that's great. So, you must not be, I didn't go down.
I got accepted there. That was my backup school, but I did pursue my $400
Congratulations.
for elementary education.
Good. Do you have any questions on what we did today?
Sorry, I'm turning my computer.
Did you have?
No.
There's still-